Hey everybody, and welcome to another physics video. In this problem, we're going to deal with energy in the presence of friction. A food shipper pushes a 14 kilogram wood crate of lettuce across a concrete floor with a constant horizontal force of 40 newtons. In a straight line displacement of 0.50 meters, the speed of the crate decreases from 0.60 meters per second to 0.20 meters per second. How much work is done by the force, and then what is the increase in thermal energy? Let's get started. Let's start with the information that we do know. The force applied by this person is 40 newtons. The mass of the crate is 14 kilograms. The displacement is 0.50 meters. And the angle is going to be 0, as both the force and the displacement are facing the same direction. The first part is easily done. Since we have all the quantities needed, we can find the work done by the force. We can just simply do 40 newtons by 0.5 meters by cosine of 0, and we can get a work done of 20 joules. All right, the second part is a little bit more tricky because we are introducing thermal energy here. So originally we understood work to be equal to the change in kinetic energy, and this was the work kinetic energy theorem. But to cover more complicated situations, it should be expressed as work equals to the change in energy, or W equals delta E. When we say this, it covers mechanical energy and non-mechanical energy. So now our expression becomes work equals delta E mechanical plus delta E non-mechanical energy. Or in this case, I'm just going to call it delta E thermal. Looking at our equation, we can also split delta E mechanical into delta U plus delta K, because mechanical energy is just the sum of both kinetic energy and potential energy. Examining the situation a little further, we know that the problem is not experiencing a change in height. And also, there is no springs involved. So with that being said, there's going to be no change to potential energy. Therefore, we can say delta U equals to 0. However, there is a change in kinetic energy as it decreases from a speed of 0.60 meters per second to 0.20 meters per second. So let's go ahead and calculate the change in kinetic energy. It'll be delta K equals 1/2 times 14 kilograms times 0.2 squared minus 1/2 times 14 kilograms times 0.6 meters per second, and then squared. And then with those, we'll get our final kinetic energy and minus our initial kinetic energy, 0.28 joules minus 2.52 joules. And as expected, we are going to lose kinetic energy since the speed is decreasing. We are going to get a delta K value of negative 2.24 joules. Since we know the work done, and we also know the change in kinetic energy, with those two values, we can go ahead and find the change in thermal energy. Using those values, the change in thermal energy is going to be 22.24 joules. Though energy is put into the system through work, more of it is lost to the thermal energy. Okay, so that concludes our problem, and thank you for watching.